If you're a developer, you know we've all lived through some massive tech shifts. But the next one? It isn't just another framework or a new cloud service. Nope. This is a fundamental change to the laws of computation itself. We're talking about quantum computing, and we're about to break down exactly why it's going to change everything for your code and, more importantly, how you can get ready for it.
And let's be super clear here, this is not some far-off science fiction fantasy. As Carl Dukatz from Accenture says, this is seismically disruptive. The folks getting their hands dirty with this tech right now are the ones who are going to lead the pack. We're not just talking about a faster computer. We're talking about a whole new kind of computer that's going to unlock brand new possibilities and, yeah, some brand new problems too.
And that brings us to the really big one, the core issue for every single developer and engineer out there. The code you're shipping today, the security protocols you completely take for granted, those optimization algorithms you've spent years perfecting, all of it could become fundamentally broken, like almost overnight. This is a direct, urgent threat to your work, and honestly, ignoring it just is not an option.
So where are we going to feel the first tremor from this quantum earthquake? It's going to be in security. The entire foundation of our modern digital world, all the cryptographic algorithms that protect everything from your bank account to government secrets, is about to face its biggest challenge ever.
I mean, just look at the sheer scale of this. RSA 2048 encryption, that's a cornerstone of the internet. A classical supercomputer would need billions of years to crack it. It's basically impossible. But a powerful enough quantum computer running something called Shor's algorithm, it could potentially get it done in a matter of hours. This isn't just a small step up, it's a complete paradigm shift that makes our current security pretty much obsolete.
And this isn't some hypothetical someday problem. This is happening right now. The National Institute of Standards and Technology, or NIST, is already making moves. They started rolling out standards for post-quantum security in 2024. Why? To combat these steal now, decrypt later attacks where hackers are grabbing encrypted data today so they can break it with a quantum computer tomorrow. And by 2030, the old cryptography we all use will officially be a thing of the past. The clock is ticking, for real.
So how on earth is any of this possible? Well, to get that, we have to look under the hood. A quantum computer's insane power comes from how it handles information at the most basic level. And it all starts by completely rethinking that simple little thing we call a bit.
You know, in our classical world, everything is built on the bit. It's simple, it's reliable, it's definitive. It's a 0 or it's a 1. That's it. Every piece of software, every app, every website we build is just based on flipping these simple binary states one after another. But the quantum bit, the qubit, just shatters that limitation. A classical bit is either a 0 or a 1. A qubit, thanks to this wild property called superposition, can be both a 0 and a 1 at the exact same time. This one change fundamentally flips everything, moving us from sequential processing to massively parallel processing. Instead of checking one path at a time, a quantum computer explores a huge landscape of solutions all at once.
So you've got these two magic ingredients, superposition and entanglement. Superposition, like we just said, is the 0 and 1 at the same time trick. Entanglement, now this is where it gets really weird. It's this deep connection where two or more qubits get linked up. The state of one instantly, and I mean instantly, influences the other, no matter how far apart they are. This linkage is what lets all the qubits work together, exploding the computer's problem-solving power exponentially.
Now, if this all sounds incredibly powerful, that's because it is. But, and you knew there was a but, right? Harnessing that power is one of the biggest engineering challenges of our time. Before we all have a quantum processor in our laptops, there are some absolutely massive physical hurdles to get over.
So here's the catch. Individual qubits are incredibly fragile. They're super prone to errors. To get around this, researchers are building something called logical qubits. Think of it like a RAID system for your hard drive, right? You use multiple physical drives to create one big, reliable, logical one. But check this out. Current estimates suggest it could take around 10,000 of these fragile physical qubits just to create one single stable, error-corrected logical qubit. The overhead is just mind-boggling.
And the headache list just keeps going. The biggest enemy is this thing called decoherence. That's where a qubit just loses its quantum magic because of the tiniest vibration or magnetic field. Then there's just scaling up. Making tons of high-quality qubits is super difficult and expensive. We just talked about error correction, which is a huge resource hog. And on top of all that, most of these machines need to be kept in cryogenic freezers, just a tiny fraction of a degree above absolute zero.
But hey, despite all those hurdles, the progress is just undeniable. And with that progress comes a whole new generation of software tools and platforms that are pulling quantum programming out of the physics lab and putting it into the hands of developers like us. So how do you actually, write code for one of these things?
The great news is, you do not need to be a quantum physicist. The big tech companies have already built SDKs to handle a lot of the complexity. You've got IBM's Qiskit, which is this huge open-source framework in Python, a really great place to just start exploring. Google's Circ is also Python-based, but it's really focused on the kind of noisy quantum devices we have access to today. And then Microsoft took a totally different route, with Q#, a brand new language designed from the ground up for hybrid systems where classical and quantum processors work hand in hand.
And honestly, here's the best part. You don't need to own one of these multi-million-dollar cryogenically cooled machines. Not at all. Cloud platforms like Amazon Braket and Microsoft's Azure Quantum give you direct access to real quantum hardware and incredibly powerful simulators. This means you can start writing, testing, and running quantum code right now from your own laptop. The barrier to entry has never been lower.
Okay, so we've seen the threat, we get the basics of the tech, and we know the tools are actually out there. So the final, most important question is, what can you, as a developer, do about it? Right now. Let's break down the actionable steps to future-proofing your code and, frankly, your career.
Here it is, your 4-step roadmap. Step 1, master the basics. Pick up a framework like Qiskit and just start building simple quantum circuits. You have to get a feel for this new way of thinking. Step 2, and this is crucial, adopt quantum-safe crypto. Start looking at the new standards from NIST and begin planning that transition now. Protect your data. Step 3, leverage quantum algorithms. If your job involves complex optimization problems, think logistics, financial modeling, start exploring algorithms like QAOA. If you're dealing with massive, unstructured search, look into Grover's algorithm. These are the things that are going to give you a serious competitive edge. And finally, step 4, embrace hybrid development. The future isn't purely quantum. It's all about learning how to use quantum processors as specialized accelerators inside the apps you're already building.
Look, quantum computing is moving from the lab into reality, and it is happening way faster than most people think. It promises to solve some of humanity's biggest problems, but it also threatens to break the very foundations of our digital world. The shift is coming, and it's going to create some incredible opportunities for those who are prepared. The only question left is, will your code be ready?